Okay. So another influence on the earth material type, I guess, is going to be the zones of weakness. So going along kind of what we talked about before, these zones of weakness are going to be the slip planes. They're going to be natural breaks in the consistency of the materials. So one of the zones of weakness that we have talked about before is going to be the zone between the bedrock and the regolith, or all the unconsolidated material on top. Other zones of weakness can be bedding planes. So whenever you have sedimentary rocks deposited, say that you have them deposited in a lake setting, so you get a bunch of shales deposited in the lake, then there's no deposition for quite some time, and then you get more shales deposited on top of those. The plane between the shale deposits is going to be a bedding plane, so that can be another zone of weakness. Other zones of weakness can be these foliation planes, which happen in metamorphic rocks. So certain metamorphic rocks, as you may know and remember, are going to be foliated, meaning have this planes. Literally, they're just going to be planes upon which the minerals are going to arrange and alineate. So the image on the right that you're seeing is going to be these foliation planes forming in a slate or what could be a phyllite rock right here. So you see that there's a bunch of planes subdividing each layer, each foliation plane, each foliation layer within that metamorphic rock. So those can also be the zones of weakness. Other very, very common zones of weakness are going to be fractures, faults, or even old landslide, I guess, plains, if you would. If any earthquake is active and it creates a fault or even just a small fracture, if, again, there is enough driving forces to drive the material downslope, then they're going to choose these zone of weakness, this fracture of the fault, to reoccur there. Another zone of weakness can be colluvium, which is a typical zone of weakness for soil slips. You'll see in your lab this week that colluvium is one of the materials in which you can find a bunch of these landslides in the Nez Perce County near Lewiston, Idaho. So again, colluvium can also be a zone of weakness. So this soil slips, as we have talked about before, that are a zone of weakness, right? Where we can get landslides to occur, or the block on top can occur on top of these zones of weakness, are going to be very highly controlled by the permeability of the material. So the permeability is going to be the ability to transmit water through a specific material. So you have this cross section here, and at the highest point you have a permeable zone, and then at the bottom part you have an impermeable zone. The permeable zone is going to be composed out of these unconsolidated material, and then the impermeable is going to be controlled by mostly bedrock. So the permeable zone, which is made out of these unconsolidated material, is in fact permeable because a lot of water can actually infiltrate through that material. There's a lot of empty spaces, pore spaces, and those pore spaces are highly connected in a way that the water can actually move through them. And so the water is going to move through all of this material that goes down, and then once it hits this boundary between the regolith and the bedrock, then the water can no longer move. It cannot, it cannot go from the permeable zone into that impermeable zone because it just cannot flow through it. So again, many a times how permeable something is going to affect very greatly the moisture content on it, right? So if we have a spring that is very wet, water is going to want to infiltrate into the soil profile, and it will only go as far as the permeable zone allows. Once the water reaches this zone of this boundary zone, then more water will accumulate and accumulate and accumulate on top of the regolith, like on the regolith, I should say. And so if it gets too wet and the driving force is enough, meaning the slope is high and so the vegetation could be low, then it is very likely that that zone of weakness is going to give in and a landslide will occur. Perhaps a more intuitive influence than the earth material is going to be this topographic relief, or the topographic slope itself. So when you have a high relief, or high gradient, I should say, you're going to have more mass wasting than if you had a low relief or a lower gradient. So if the slope is steeper, is what that means, then you are going to have more mass wasting. So why is that? It's because you're going to have more driving forces than you would resisting forces. So if you go back to the safety factor, your resisting force is small, your driving force is large, so that makes the safety factor small, makes it under 1. So it makes it unstable and easy for it to give in and have that mass wasting event, that landslide. Okay, so the higher the relief or the slope, the easier it will be for you to have landslides or mass wasting events. Sorry, guys. Boy. Okay, so we're talking about the... One second, everybody. Wow. I don't even know. Okay. All right. Sorry about that. Okay. So we were talking about in the previous slide about the topographic relief being one of the influences that we have on whether or not we're going to get a mass wasting event. Another big thing to have in mind is going to be this angle of repose. So the angle of repose is going to be the angle at which a material is going to sit, and whether that angle of repose is high and you can get a mass wasting event, or low and you don't, depends very greatly on the material itself. So as you're seeing here at the bottom, if you have a material that is only fine sand, the angle of repose, meaning the angle at which things are stable still, is going to be 35 degrees. The angle of repose for coarse sand is going to be 40 degrees. And the angle of repose for angular pebbles is going to be about 45 degrees, meaning whenever you have these materials at those angles, then, or lower, then the slope is stable. You are not, or very likely, you are not going to get mass wasting events. However, if the angle is increased, so if say you have a material that is only fine sand and the angle reaches 55 degrees, then it's very, very highly likely that you are going to get a mass wasting event. Okay? So along those lines, snow avalanches are going to be a little bit different than most of the other materials. They're going to have a sweet spot at which they are going to, flows are going to occur. These avalanches are actually going to happen. And that angle is going to be about 38 degrees. So at 38 degrees is the angle at which slab avalanches tend to occur. So where there is enough or not too much, the angle is not too big so that snow can actually settle and stay, but it is not too shallow so that it will simply not have enough driving force for it to move down slope. So at 38 degrees is kind of that sweet spot where you can get enough snow accumulation, and it's also steep enough so that there's enough driving forces to drive it downhill. So it's a very kind of scary place to be at. However, if you have low angles in the hill, then there's not going to be enough driving forces. And then if you have very high angles, they're so high that any snow that falls on them is pretty much going to instantly move downwards into a more shallow angle. So that is important to keep in mind. So this angle of repose in snow is going to be controlled again by the temperature, by the wetness, and by the shape of those snow grains, but it is pretty safe to say that around between like 30 and 40 is going to be kind of a sketchy, I guess 30 and 45 pretty much is going to be a sketchy point to be at in terms of that slope and the possibility for slab avalanches to occur. Okay? So not talking about snow anymore, but just simple kind of slope dynamics. When you have very steep slopes, the most likely type of mass wasting event that you're going to get are either going to be rock falls, avalanches, and then soil slips. If you have moderate slopes, the most likely kind of mass wasting event you'll see are going to be earth flows. And then when you have gentle slopes, the most likely type of mass wasting event you'll see are going to be things like creep. Okay? Okay, so because having mass wasting events are so dependent on the moisture and on the water content, they're also going to depend very highly on climate. So climate is going to basically be driven by both moisture and temperature. Temperature itself is going to drive whether that moisture that you have is in the form of liquid water or solid water, right? Kind of like snow or even hail. So the influence on climate is going to be also very great in determining what type of mass wasting event we're going to get. So the amount and the timing of that water is also going to influence what type of mass wasting event you're going to get, if at all, and the type of abundance of the vegetation where you're at might determine whether the vegetation is going to act as a driving force or a resisting force, or maybe sometimes of the year is a driving force, other times of the year is a resisting force. So let's have this example where you have a subhumid to humid region, kind of like the tropics, perhaps where I'm from in Colombia, is pretty much like that. So in this kind of region, you're going to have very thick soils and lots of vegetations. So for the most part, the vegetation is going to act more likely like a driving force because it's so heavy and everything is so moist. It's going to act as a driving force, just adding weight to the slope itself. But in this kind of region, you're going to get things like complex landslides. So you're going to get earth flows and creep, and you're also going to get a bunch of different slides, flows, maybe just earth flows and creep as the flows, but you might also get slumps. So those are going to be the type of mass wasting events you're going to get. And then for more arid regions, perhaps like southern Idaho over here, you're going to have fairly limited soil. The soil is not going to be as thick. And also, vegetation content is not going to be as great. So if you do have vegetation, it's mostly going to act as a resisting force that is opposing the flow downhill. But because of those two things, and because of the fact that it's fairly low moisture, it's an arid region indeed, whenever you do have water, the most likely mass wasting events you're going to get are going to be rock falls, again because of the frost wedge action, and talus slopes. You're going to get debris flows, and debris flows in this case are going to form either by volcanic eruptions or by kind of flash floods are going to be the drivers for the debris flows to occur. And then you're also going to get these shallow soil slips. Okay? In this case, the influence of vegetation is going to have a very great effect and is going to be dependent on all of these things. So the vegetation cover itself is going to be, it's going to be, changed by the climate, by the soil type in that area, by the topography of it, and by the different history of fires in the area as well. So I'm going to go through these slides kind of fast, but they're online so you guys can check them out. So again, influencing climate is going to affect greatly what type of vegetation you have and how much. Soil type is also going to change that. The topography. and also the fire history, how much vegetation you have.